Welcome to my channel. In this session, we will discuss points of concurrence in triangles like Orthocenter, Centroid, Incenter, Circumcenter. Then apply them and solve a question there. This is the 11th in the series of geometry videos that we are making. What is Orthocenter? Orthocenter is the point of concurrence of altitudes. If you look at this, AD is the altitude drawn to BC. You can see this is perpendicular. B is the altitude drawn to AC. And similarly, CF is the altitude drawn to AB, and they meet at a point. So that point of concurrence is called orthocenter. So here they meet at O. This O is the orthocenter. The next point is angle at the orthocenter and its opposite angle are supplementary. For example, if I take angle BOC, its opposite angle is A, that is angle BAC. Sum of them is 180 degrees. Angle BOC plus angle BAC is 180. We can extend this to other angles also. If I take AOB, angle AOB, what is its opposite angle? C, that is angle ACB equals to 180. Or if I take AOC, this one, what is its opposite angle? B. Angle AOC and its opposite angle B means angle ABC equals to 180 degrees. So these are a couple of interesting points on orthocenter. Next is centroid. Centroid is the point of concurrence of medians. You know, if DEF are the midpoints of the sides, we had a session on medians before wherein we discussed median is a line segment that joins the midpoint to opposite vertex. So AD is a median, BE is a median, and CF is a median. All the medians concur at a point. That point of concurrence of medians is called centroid. Here they are meeting at G. G is the centroid of this triangle. Now, centroid divides the median in the ratio 2:1. Which is two parts, which is one part. From vertex to centroid, two parts, and centroid to midpoint, one part. In other words, AG is to GD will be 2:1. Or if I take from vertex to centroid, BG will be two parts. G to E, that is midpoint, that will be 1. BG is to GE will be 2:1. Or if I take CG is to GF will be 2:1. Right? So these are a couple of interesting points on centroid. Next we will take incenter. Incenter is the point of concurrence of internal angular bisectors. If you look at this is angle A. If you draw the angular bisector, similar which divides this into two equal parts, this is angle B. If you draw the angular bisector for this, similarly for angle C, if you draw the bisectors, all these bisectors when you extend, they will meet at a point. That point of concurrence is called incenter. So here we are writing I. This I is the incenter. That is the first point. Second one, the angle at the incenter is 90 plus half the opposite angle. For example, if I take angle BIC, it is 90 plus half of the opposite angle. What is the opposite angle? A. So 90 plus A by 2. If I extend this logic, if I take this AIB, what we can write angle AIB can be equal to 90 plus, what is the opposite angle for this? C by 2. Or if you take this particular angle, angle AIC will be 90 plus what is the opposite angle for this? B by 2. So this is about angle at the incenter. Next, from incenter, taking this as center, we draw a circle which will touch all the three sides internally. Because it touches all the three sides internally, you know, from center of the circle to any point on the circle will be equidistant. So from incenter, the distance to all the three sides will be same. That's what we call it as in radius, small r. In one of the earlier sessions on area of triangles, we discussed that area of a triangle is R into S, where R is in radius we discussed. This is R. From incenter to perpendicular distance to any of the three sides is same, that is called in radius. You can see the perpendicular distance from incenter to all the three sides is equal. This is called in radius. Why it is perpendicular distance means This is the radius of this circle. For this circle, this is the radius. This particular line is, that is AB, is tangent. So the angle between radius and tangent is 90 degrees. When we come to circles session, we will discuss this point in detail, right? So the perpendicular distance from incenter to all the three sides is equal. It is called in radius, right? So this is about incenter. Next one we'll take up circumcenter. Circumcenter is the point of concurrence of perpendicular bisectors. What do you mean by perpendicular bisectors? Suppose if I take DEF for the midpoints, if they are the midpoints, and if I take from D, if I draw a perpendicular, you may have a doubt, will it go through opposite vertex? May or may not. If other two sides are equal, it will go through opposite vertex, otherwise it may not be. Because from the midpoint, if you draw perpendicular, it is not necessary that it should go through opposite vertex, may or may not. Similarly, from this midpoint, if you draw a perpendicular, see, because you are drawing from midpoint a perpendicular, we are calling it perpendicular bisectors. Similarly, all these meet at a point. That point of concurrence of perpendicular bisectors is called circumcenter. Next, from this circumcenter, we take this as the center and draw a circumcircle which circumscribes the triangle. Which circumscribes the triangle means which will be passing through all the three vertices. Because it passes through all three vertices, from circumcenter, the distance to all the three vertices will be same, because from center of a circle to any point on the circle, you should have the equidistant, and this is the radius of this particular circle. The circle is a circumcircle for the triangle, hence we call it as circumradius. This SA, SB and SC are equal, we call it circumradius. The third point is the angle at the circumcenter. Suppose if I take this angle BSC equals to twice of its opposite angle. Let me show you. The distance from circumcenter to all the three vertices is equal. We call this as circumradius, capital R. You know, in one of the, again going back to that session on area of triangles, one of the formula we have discussed for area of triangle is ABC by 4R, where R is the capital R is the circumradius we discussed. This is circumradius, right? Next, as I said, angle at the circumcenter is twice the opposite angle, means angle BSC is twice opposite angle BAC, or you can say in short term A, right? So this I have already told you, SA equals to SB equals to SC, we call it circumradius. Next one, the angle at the circumcenter is twice its opposite angle. As I said, angle BSC equals to twice of angle BAC. Similarly, we can say angle B, if I take this angle ASB, ASB is this, which will be twice of its opposite angle, that is twice of angle ACB, I can say. Or if I take this particular one, angle ASC will be, this one will be twice of its opposite angle, twice of angle ABC. Again, this comes from the concept of circles, because angle subtended by a chord at the center will be twice the angle subtended on a point on the circle. Again, that point we will discuss in detail in the session on circles there. So these are few important points on the 4 points of concurrence: orthocenter, centroid, incenter and circumcenter. Now let's apply these points and solve a question. PQ are the orthocenter, incenter and circumcenter of triangle ABC respectively. If angle BQC is 115 degrees, find angle BPC and BRC. What is Q? PQ are orthocenter, incenter means Q is incenter. If I draw a triangle ABC, if I say Q is the incenter, angle BQC is going to be, angle BQC is 90 plus half of the opposite angle, that is A by 2. But we know angle BQC is 115. 115 degrees is equal to 90 plus A by 2 means A by 2 equals to 115 minus 90, that is 25 degrees, or A equals to 50 degrees. Once A equals to 50 degrees, what is angle BPC? What is P? P is the orthocenter. Let me explain drawing one more diagram. In triangle ABC, now I got angle A as 50 degrees. 50 degrees. Now orthocenter, if this P is the orthocenter, angle at the orthocenter and its opposite angle are supplementary angles. So angle BPC plus angle A together is 180 degrees. If angle A is 50 degrees, angle BPC is 180 minus 50, 130 degrees. Next, angle BRC, what is R? R is the circumcenter. Let me again draw one more diagram to explain this. In triangle ABC, where we got angle A 50 degrees, if R is the circumcenter, the angle at the circumcenter is twice its opposite angle. So angle BRC is twice of its opposite angle A, that is twice of angle BAC in other words. And we know angle A is 50 degrees, so 2 times of 50, it is 100 degrees. Right? So this is how we can find angles at incenter, orthocenter and circumcenter. Students, for more on geometry, please reach my profile on Udemy. The link is given below where you find a comprehensive course on geometry. Thank you.